Hello class, welcome to our lesson today from section 3.4. There's two main formulas that we're going to be looking at today and in the future classes. They deal with what's known as linear and angular speed. So today we're going to give some basic info and go through some questions together, and then over the next couple of days I'm going to do a few examples, and then I'd like you to try to work on some additional questions too. So let's get started with the formulas. First is angular speed, which is how fast an angle is moving. So this would be like radians per second or degrees per second. Angular speed is always denoted by the Greek letter omega. Okay, so it looks like a W. So you might hear me say W. I'm trying to relate it to what you would understand with the letters, but realize it's also omega. So I'll be using both of those probably at different points throughout the lessons. Theta is the angle. Now notice the rules are the same as arc length and area. It has to be in radians. And then divide by time. So that's how fast an angle is moving. So omega equals theta over time. That's angular speed. And then linear speed is how fast the point on the edge is moving. So angular speed is how the angle is moving. Linear speed, how fast it's moving around the edge. This formula has two parts to it. I wrote over here they can kind of be used separate. Don't feel like you need all of this at once. They're all equivalent to one another. So the velocity, or v, linear speed, equals the arc length, s, divided by time. Or the linear speed equals the radius times omega, which is the angular speed from the last slide. Okay, either of the two can be used, and whatever information is given to you will help dictate what your answer should be. So this information gives you a radius, gives you omega, and gives you time. You're trying to find the angle. Okay, so the best way to find the angle is to use omega equals theta over time. So omega, angular speed, is pi over 10, equals theta, which is unknown, divided by 4, because it's 4 seconds is the time. One option here is you could just cross multiply it. That might be easier to find in terms of pi answer. You could also just multiply the 4 to the other side. Either way, you should get 2 pi over 5, and remember, that's always radians. It will never be written, but if it's degrees, it'll have the degree symbol. If it's just find theta based on the other info, it's going to be in radians, okay, for those situations. The next question deals with find how fast something's traveling or find the distance around the edge. So you still have to know the arc length formulas. Okay, so S equals r theta. S is the arc length, equals the radius, which is 30, times theta, which you found on the previous slide, which is 2 pi over 5. You just multiply those together, you get 12 pi centimeters. To be honest, most of those questions are either going to be in terms of pi, but you're probably looking for more decimals because you're not going to tell someone, hey, move 12 pi centimeters, for example. So just be careful on the directions for your homework for a question like that. Next is find linear speed. We'll find it in two ways. First is s divided by time, okay, or arc length divided by time. We just found arc length to be 12 pi, and then the time was 4 seconds. That ends up being 3 pi. And then the units here are centimeters per second because velocity or speed or angular or linear speed, would always be your distance divided by time. So that's why it's centimeters per second. The other option is you can do the radius times omega. The radius was 30. Omega was pi over 10. Okay, remember back to the first question we found here, which was find omega, using omega. So omega pi over 10 based upon that information that you've already got. And then that still gives you 3 pi centimeters per second. So it doesn't matter which option you pick. You get to decide which version makes the most sense to use. In this case, it didn't really matter which one we picked. But with the given info, you probably want to pick the second version because you're already given omega and you're already given the radius to help answer that question. Okay, so this question gives you theta, gives you time, solve for omega. So in this case, this question is here because I want to talk about the complex fraction. So theta is 2 pi over 5 and then divided by 10 seconds. You just want to rework with that or rework it a little bit and make it multiply by 1/10. Anytime you have a complex fraction, just do times its reciprocal. And then there should be some cross simplifying. Make sure you're able to get to this pi over 25 radians per second. And the reason it's radians per second is because the angle's in radians. Okay, you want the angle to be in radians, and then the omega piece will be in radians per second. The next question asks you to solve for theta and solve for omega. Probably easier to solve for omega first using v equals r omega. So v is given to you, 107.7. Radius is given to you, and then divide that out, and you'll get radians per second. Why is it radians per second? Well, it's always radians, but then per second because the velocity or the angular or linear speed, is also per second. Once you have omega, then you work backwards to be able to find theta. So omega, or the w variable, equals theta over time. You know what time is, multiply it to the other side. You just multiply those two pieces together and you get omega. Theta. Theta is in radians. This often looks like a degree symbol once the numbers get larger, but remember this is radians. So if they ask you for degrees, you have to go to the beginning of the lessons, which is, I got to multiply by 180 and divide by pi. So keep that in mind. You may be asked to find things in degrees. You just have to flip-flop things around in order to find it. The next question is find omega. Well, to find omega, you probably need to find velocity first, or the linear speed, by taking s divided by time. So the arc length, 8 pi over 9 divided by 12. Remember, if you see a complex fraction, just take the first fraction, multiply by its reciprocal. Okay, for the denominator, cross-canceling will work here, and then you get your answer. I know you can plug things into calculators a lot easier now than what you used to be able to, but by the time you plug some of those things in, I can already be done with some of that as well. So keep that balance in mind as you're going through your questions. And then plug that in for V, and then you have R. Anytime you want to get something by itself and there's a fraction coefficient like this 4/3 here, remember you're going to multiply by the reciprocal, in this case 3/4. So you multiply both sides by 3/4, and you're probably looking for an answer in terms of pi for radians per second. So I use the velocity or linear speed formula to find that piece, and then I replug that in to find omega. It's probably the easiest way to find that answer. Obviously, you could set the two equations equal to one another, kind of like the gears question. So it shouldn't really matter which option you pick. Okay, that's the end for today's lesson. When we get back together for the next lesson, we're going to continue on with linear and angular speed. You want to make sure that you understand each of the questions that we've looked at, or at least have them written down, so you know how to solve for the missing variables. And then we're going to look at applications of these things in order to solve different questions as we're looking at linear and angular speed. Have a good day, everybody.